calculate the binding energy of an artificial satellite of mass 80 kg revolving at a height of 1600 km from the Earth's surface. I am going to take this as an Earth, okay, keeping the radius of Earth as an R and mass of an Earth as an M. Now, a satellite is revolving around the Earth's surface in the height of h is equal to 1600 kilometer. In the height 1600 kilometer. Okay. Now, our aim is to find the height of 1600 kilometer from the surface of the Earth. So, from the surface of the Earth, what is the height we need to find? So, from this is R, that is Earth radius is R, and this one is h. So, what is this space now? R plus h. R plus h. Now, what is the formula for binding energy? Our aim is to calculate the binding energy of the satellite. Keeping here the mass as in capital M, Earth mass as in capital M, the satellite is moving here in this orbit. I am keeping this mass as in small m, satellite mass as in small m. Now, the binding energy formula Gmm divided by 2r plus h. We are getting the height from the surface to the height. Satellite height is r plus h. Now, G is a constant value. So, value of G is gravitational constant. So, 6.67 into 10 power minus 11, and they given the mass capital M, mass of the Earth. We need to know this one, this value 6 into 10 power 24 kg, 24 kg, and they given the small mass, that is satellite mass, as 80 kg. And the radius of Earth, capital R is the radius of Earth. Radius of the Earth is 6400 kilometer. This is a constant value. Radius of Earth is 6400 kilometer. Now you substitute in this formula. G is gravitational constant 6.67 into 10 power minus 11 into the mass of the Earth is here 6 into 10 power 24, and satellite mass is 80 divided by 2. R is the radius of Earth, that is 6400 kilometer, and height of the from the surface to here is 1600. Okay. Now, this can be written as, it is in kilometer, so convert into meter, 10 power 3. Now, the binding energy is equal to, when you are substituting this value, you will get 20.01 into 10 power 8 joule. And this can be written as now 2 into 10 power 9 joule. So, the binding energy is 2 into 10 power 9 joule. So, the option is here number 2, 2 into 10 power minus 10 power 9 joule. Moment of inertia of a ring of mass 4 gram, the radius is equal to 1 centimeter about an axis passing through the edge, and it must be parallel to the natural axis. Here I am taking, this is a ring causing the axis of rotation. This is the axis of rotation. The moment of inertia passing through the axis of rotation is IC. Here in the question they given at the edge, we want to draw a tangent at the edge here, which must be parallel to the natural axis. This is parallel to the natural axis now. Now I am going to take this moment of inertia as I0. Okay, this is I0 now. Now moment of inertia IC, which is passing through the center, is equal to mr square. M is the mass of the ring and r is the radius of the ring. This is capital R, radius of the ring. Our aim is to find which axis, the above an axis passing through the edge and parallel to the natural axis. And this distance, I am going to take this distance as in d, small d. Now, this is parallel axis theorem. According to the parallel axis theorem, I naught is equal to, our aim is to find now the moment of inertia of this ring for the particular axis, this axis, okay, for this axis. So, IC is nothing but the moment of inertia which passes through the center, the axis passing through the center, plus m d square. M is the mass of the ring and d is the distance between the two axes now, parallel axes. IC represent here, m they given the mass as in 4 gram into r square, r is 1. So, 1 centimeter. So, here 1 into 1 centimeter into 1 centimeter. So, this can be written as now 4 centimeter square, and here the mass is represented in gram. So, 4 gram centimeter square. Now, I naught is equal to 4 gram centimeter square plus then mass they given as 4 and d value is equal only to the edge as well as parallel axis. So, here also 1, r is equal to 1 only, r is equal to, that is d is equal to here 1. So, we can write g centimeter square. Now, I naught is equal to 8 gram centimeter square. So, the option is 8 gram centimeter square. A 6 meter long copper wire of cross-sectional area 1.2 centimeter square, it is stretched by a force of 4.8 into 10 power 3 Newton. Find the Young's modulus, they given the Young's modulus value. We need to find the increase in length of the wire now. Now, the wire, we are taking the wire length as, original length as 6 meter. Okay, applying a force to this wire now. So, there is a change in length occurs in the wire. This we are going to take, that is del L. Our aim is to find what is the change in length of the wire now. According to the Young's modulus, we are taking the symbol for the Young's modulus as y is equal to stress divided by strain. Stress is nothing but force per unit area. So, force per unit area and strain is change in length divided by original length. So, change in length is del L and original length is an L. Now, Young's modulus can be written as F divided by A del L into L. Now, here our aim is to find what is del L, that is change in length. So, change in length del L is equal to FL divided by YA, Young's modulus into area of the cross section. Now, given, what is the given value? Given that force is equal to 4.8 into 10 power 3 Newton. And length, original length, they given the original length as an 6 meter. And area of cross section, they given 1.2 centimeter square. We need to convert that centimeter into meter. So, converting the centimeter into meter, we are representing here 10 power minus 4 meter square. So, here, applying this formula now, force is 4.8 into 10 power 3 into the original length we are getting 6 meter divided by Young's modulus value they given as 1.2 into 10 power 11 into area of cross section as 1.2 into 10 power minus 4. On substituting this value, you will get the change in length value as 2 millimeter. So, this change in length is now 2 millimeter. Option is number 1, 2 millimeter.
In this following reaction, what will be the structure of the product? Here, the amino acid which leads to the formation of Zwitter ion. What is Zwitter ion? In aqueous solution, the amino acids are CH, COOH, NH2. This is the amino acid. In this amino acid, this carboxylic group which donates a proton to the amino group. This amino group which accepts this proton. So, it leads to the formation of dipolar compound, that is R CH COO minus NH3 plus. So, the answer is option 1. This is the dipolar compound. This is Zwitter ion. Molar conductivity at infinite dilution for NaCl, HCl and sodium acetate are 126.4, 425.9 and 91 Siemens centimeter square mole per minus 1. Calculate the molar conductivity at infinite dilution for acetic acid. First we have to write the reaction. The reaction is CH3 COONA plus HCl which gives CH3 COOH plus NaCl. Here we have to calculate the molar conductivity at infinite dilution for acetic acid. CH3 COOH equal to molar conductivity at infinite dilution for CH3 COONA plus molar conductivity at infinite dilution for HCl minus molar conductivity at infinite dilution of NaCl. The values are, the molar conductivity of sodium acetate is 91 minus molar conductivity of HCl is 425.9, 5.9. The molar conductivity at sodium chloride is 126.4. So, when solving this, we have to get 390.5 Siemens per centimeter square per mole. So, the answer is 390.5 Siemens centimeter square per mole. So, the option 2 is correct. Choose the incorrect statement. In the first statement, boron occurs as borax, kernite and orthoboric acid. Borax is Na2B4O7 10H2O. Then kernite is Na2B4O7 4H2O, and third one is orthoboric acid. It is H3 BO3. So these three are boron. So first statement is correct. Second statement is boron is a very rare element in earth crust. This statement is also correct. In third statement, there are two isotopic forms of boron are present. Here they are giving B9 and B10. But the actual isotopes are B10 and B11. It is B10 is 19%, B11 is 81%. So this third statement is incorrect statement. So the answer is 3.
Which of the following statement is incorrect? The options given are: the cyclic photophosphorylation involves both PS1 and PS2. Both ATP and NADPH2 are synthesized during the non-cyclic photophosphorylation. Stroma lamellae have PS1 only and lack NADP reductase. Grana lamellae have both PS1 and PS2. In the given option, we need to find the incorrect statement. The first option is the cyclic photophosphorylation involves both PS1 and PS2. In this option, the cyclic photophosphorylation usually involves only PS1 and not PS2. So the first option is wrong. Both ATP and NADPH2 are usually synthesized during the non-cyclic photophosphorylation. Hence this option is correct. And the stroma lamellae have only PS1 and lack NADP reductase. This option is also correct. Grana lamellae have both PS1 and PS2. This option is also correct. So the correct answer is cyclic photophosphorylation involves both PS1 and PS2. The respiratory quotient value for carbohydrate conversion to organic acid. So the respiratory quotient means where RQ is equal to volume of carbon dioxide evolved by volume of oxygen consumed. So this is the formula for respiratory quotient. Here the question asked is the RQ value for carbohydrate conversion into organic acid. So first we need to write the equation. First the carbohydrate here is C6H12O6, which is in glucose, which gets converted into organic acid, that is malic acid. The formula for malic acid is C4H6O5. In this there are 3 molecules of oxygen is consumed and 3 molecules of water is evolved. So we need to substitute in this formula. So RQ is equal to, in that equation the carbon dioxide does not evolve. So 0 molecules of carbon dioxide and 3 molecules of oxygen is consumed. So 3 molecules of oxygen. So the RQ value of carbohydrates conversion into organic acid is 0. So the answer is option 3, which is equal to 0. So usually this type of conversion that occurs in the succulent plants, where the carbon dioxide produced is utilized for carbon fixation. That's why the carbon dioxide does not evolve, it is used for the carbon fixation process. Choose the incorrect pair. First they have given the essential plant nutrition which is required for the plant growth and development. Here they are given their main functions. First, potassium, maintenance of turgidity of cell, and second one is zinc, which is used for synthesis of ethylene, molybdenum, nitrogen metabolism and boron polon germination. In this, the wrong option one is zinc normally is used for the synthesis of axin and also it helps to activate the enzymes called carboxylase. So the wrong option is zinc. So they are given it is used for the synthesis of ethylene. So it is the wrong option and it is the correct answer.
In ECG, end of ventricular systole is represented by the options are T wave, end of T wave, P wave and end of P wave. So the correct answer is option 2, end of T wave. Why? I will explain this. Okay. So here we all know that ECG has P wave, QRS complex and T wave. P wave represents atrial depolarization. Okay. So the atrial depolarization occurs and after that atrial systole occurs. QRS complex represents ventricular depolarization. So as QRS complex occurs, after that the ventricular systole occurs. And T wave represents ventricular repolarization. So the ventricular systole ends at the end of T wave and ventricular diastole begins. So ventricular diastole occurs after T wave. So thus the answer will be at the end of T wave, end of ventricular systole occurs. Coming to other options, we can see that T wave represents ventricular repolarization, P wave represents atrial depolarization and end of P wave, atrial systole begins. So for this question the answer will be option 2, end of T wave, which represents end of ventricular systole. Select the correct statement about sickle cell anemia. So they have asked about sickle cell anemia. The options are glutamic acid is substituted by alanine. Substitution occurs at 4th position of beta globin chain. It is a sex-linked recessive disorder. Under low oxygen tension, RBC becomes sickle shaped. So we have to select the correct statement. Coming to the first one, in sickle cell anemia, glutamic acid is substituted by not alanine. Okay, it is substituted by valine. Second statement, the substitution occurs at the 4th position. No, it occurs at 6th position of beta globin chain. Correct. It is a sex-linked recessive disorder. No, it is an autosomal disorder. So it is not sex-linked disorder. Under low oxygen tension, RBC becomes sickle shaped. Yes, this point is correct. So option 4 is correct. Here we can see that. So here this is the normal HbA beta globin chain which contains glutamic acid in the 6th position. Okay. Here in HbS, in sickle cell anemia, the glutamic acid is substituted by valine. So that's why the option 1 is wrong. It is substituted in the 6th position. 1, 2, 3, 4, 5, 6. So it is substituted in the 6th position, not in the 4th position. It is an autosomal disorder, not a sex-linked disorder. So the parents may be carriers and the child gets the disease. Whereas under low oxygen tension, RBC becomes sickle shaped. So under low oxygen tension, RBC becomes sickle shaped. Thus the 4th point is correct, whereas other points are wrong. So the option will be option 4. Under low oxygen tension, RBC becomes sickle shaped. The hormone produced only during pregnancy is. So they are asking about the hormone produced only during pregnancy. The options are relaxin, HCG, estrogen, progesterone, relaxin, luteinizing hormone and estrogen. All these hormones are produced during pregnancy, but which are the hormones produced only during pregnancy? The correct option will be option 1, relaxin and HCG. So the three important hormones produced only during pregnancy are relaxin, human placental lactogen and human chorionic gonadotrophins. So these hormones are produced by placenta and they are produced only during pregnancy. Relaxin, it helps in relaxing the pelvic musculature during labor. HPL, it helps in metabolism, in glucose and fat metabolism of the mother. And HCG, it stimulates the corpus luteum to secrete progesterone. So these are the functions of these hormones. So for this question, the option will be option 1, relaxin and HCG.